Hi guys, Dr. Diaz here again. I'm going to try to solve some of the problems from the review, since I get email from some of you asking about the answers. But can I give you the answer to all the questions? Because remember, I'm going to most of those is going to be on the test. But I will tell you more or less how to solve this one. The other thing you need to do is read those PowerPoints or the textbook, in particular the one that it talks about the brief. It says brief magnetic field and magnetic force. Read that one because it has all the rules. I mean, all the laws like Ampere's law, and I'm just going to use it here without telling you what exactly it is. You're supposed to read those things. So read a little bit about Ampere's law, magnetic forces and magnetic field. And what I'm going to do here is, well, solve the problem. So look at this problem. This one says a very long wire generates a magnetic field of 0.005 times 10 to the minus 4 Tesla. Or you can say like 10 to the minus 6, 5 to 10 to the minus 6. At a distance which is 3 millimeters, and they ask you what's the magnitude of the current. So this problem is actually a problem using Ampere's law. Ampere's law is right here. Remember that one? Ampere law basically says that the integral, closed integral of line, the magnetic field times ds line is equal to the permeability times the current enclosed, right? So in this case, when the current goes through a wire, it will generate a magnetic field. It looks like kind of a circle, in form of a circle, but we actually want to know how much is the intensity, actually how much is the current, if we know that a point P from the wire, the intensity of the magnetic field is this. Okay, so at point P, we're going to calculate how much is the current according to this if the intensity of the magnetic field has been calculated or measured, and is this number, 0.005 times 10 to the minus 4 Tesla. And we know that the distance between the wire, let's say pull short kind of thing, the center of the wire to the point P is 0.003 meters. This is 3 millimeters. Okay, so using Ampere's law, we have the closed integral of the magnetic field times ds. It's going to be mu enclosed, and in this case, this form, what it's going to be forming here, the magnetic field looks like the circumference. Right, that will be the form. Distance ds will be for this kind of magnetic field 2 pi r. You can look at the definition, the way it solves in the PowerPoint. It tells us something look like this. It's equal to mu. Let's put I e enclosed. Then we divide here, or we solve here for what? For the current. Solving for the current, we will have what? The I enclosed is going to be equal to what? B times 2 pi r divided by mu naught. And if you remember, mu naught is equal to 4 pi times 10 to the minus 7 Tesla meters ampere. Well, let's put all the numbers here. This is going to be 2 pi times the distance, which is 0.003 meters, times the magnetic field B, which is 0.005 times 10 to the minus 4, these are Teslas, divided by mu, which is 4 pi times 10 to the minus 7 Tesla meter ampere. And if you do this, you get something like 0.075 amperes, right? Which, okay, well, the answer, if you move the zero here, 1, 2, actually I think I'm missing the zero here. Let me see this. Yep, I'm missing the zero here. So O, the same as you crossing the point 1, 2, 3, 7.5 milliamperes. Okay, this is actually for problem 21. Let's do now another one. Now this problem 26, here's the answer, or more or less. But look what it says. It's asking, it's telling you, a solenoid is wound with 470 turns on a form of 4 centimeters in diameter and 50 centimeters long. and it carries a current as shown. Well, where's the shock? Well, we're probably missing the diagram, but I'm going to show you this in a second. And the current produces a magnetic field of 4.1 millitesla at the center, and they're asking you to calculate the current. So here we go. Ta-da! Here's the solenoid. Now look here. Inside the solenoid, the magnetic field is going to be uniform. The magnetic field lines look like this: uniform, uniform, uniform. Except when it goes here to the edge, it starts doing like something like this, something like this. But inside the solenoid, the magnetic field is uniform. So that means when you do the integral, the magnetic field here of the equation is going to be n mu I. And why n? Because n is represented a number of turns. That's why they have an n here. And then solving here for b, because this is going to be line b l, because the direction of magnetic field is going to be, well, let's put mu n I. Right. Now solving for the current, we will have what? BL divided by mu naught n is equal to I. Now we substitute everything we know. Magnetic field is 4.1 times 10 to the minus 3 teslas. The length is 50 centimeters or 0.5 meter. The constant mu, 4 pi times 10 to the minus 7 Tesla meter amperes. And the number of turns is 470. And if you do this, the answer is going to be 3.47 amperes, which actually is closer to 3.5. Okay, hope this helped. Now let me see if I can do another one. This one, number 28, which actually I think is in your reviews, probably is number 19. This one's actually, here's the answer, how to solve. The only thing you have to do is substitute the magnetic field, which is given here as 1 Tesla. The length, well, the length here is 3 centimeters, which you have to change into meter. And what else? Then the number of turns, which is 8,942, and this is a constant, and the answer is going to be B. Try this one, you guys, by yourself. Well, here's the formula you need to use. For this one, number 18, you use a sort of an equation. It's basically like a ratio. It goes something like this. If you look at the PowerPoints, it tells you more or less all this equation and answer where it comes from. I mean, the equation coming from. For 18, you have to use some sort of a ratio. Look at the PowerPoint. They tell you more of this equation. I think it's like slide 26 or something. But here it is. The ratio is like B1 L1 is equal to B2 L2. And let's assume that B1 is the magnetic field of the solenoid that has a length of 18 centimeters, and this is 2 Teslas. L1 is 18 centimeters. You can put it like 0.18 meters. B2, we don't know. That's actually what we're looking for. And L2, they're telling you now that it's being stretched to 0.29 centimeters. So now using this equation, solving for B2 is equal to what? B1 L1 divided by L2. And if you do this, you just substitute the number, you get the answer is going to be this one, 1.2 ampere. About 1.2 Tesla. Okay, guys, hope this helped a little bit. Remember, I cannot give you the answers of all the review. I just did some of these. So you work on those things, okay? See you later.